Welcome, everyone. I'm excited to kick off today's presentation with our first slide, Symmetry in Everyday Life. This is our cover slide, so I want to warmly welcome you all and introduce the topic with enthusiasm. We'll be exploring how symmetry appears all around us in daily life, sometimes obvious, sometimes subtle. Over the next few slides, we'll look at different examples, the science behind it, and why it matters. Let's get started and enjoy the journey into the fascinating world of symmetry. Now, let's move on to the second item in our contents, line symmetry. This concept is all about how a shape can be divided into two parts that are mirror images of each other. Imagine drawing a line straight through a shape, and on either side, the parts match perfectly. That line is called a line of symmetry. It's a key idea because it helps us understand the balance and harmony in shapes and objects. Recognizing line symmetry can also make it easier to identify or create designs that are visually appealing. As we explore symmetry today, keep in mind how this concept applies not just in math, but also in art and nature, connecting to the broader theme of understanding the beauty and structure in the world around us. Let's talk about symmetry and how it plays a role in our daily lives. You might be surprised to learn that symmetry is everywhere, from art and architecture to textile designs, and even in car manufacturing. For example, many buildings and bridges rely on symmetry for stability and aesthetic appeal. In textiles, symmetrical patterns create harmony and balance in fabrics. Car manufacturers use symmetry to improve aerodynamics and visual appeal. Even in traditional practices like Rangoli, symmetry helps create beautiful, balanced designs. So, throughout this presentation, you'll see that symmetry isn't just a mathematical concept. It's a fundamental part of how we design, create, and appreciate the world around us. Now, let's talk about line symmetry. A figure has line symmetry if you can draw a line through it that divides the shape into two parts that are exactly the same. We call that line a line of symmetry. Some figures may have no lines of symmetry at all, while others can have one, two, or even multiple lines. For example, look at the equilateral triangle. It has 3 lines of symmetry, each running from a vertex to the midpoint of the opposite side. The isosceles triangle has exactly 1 line of symmetry, which runs through its vertex and the midpoint of the base. A square, on the other hand, has 4 lines of symmetry, 2 diagonals and the 2 lines that bisect its sides. The circle is a special case because it has an infinite number of lines of symmetry. You could draw a line through its center in any direction, and it would still be perfectly symmetrical. The rectangle, like the square, has 2 lines of symmetry. Those bisect the sides and run through the midpoints. Finally, the scalene triangle has no lines of symmetry at all, since all its sides and angles are different. Understanding how many lines of symmetry a shape has helps us recognize and classify different figures based on their symmetry properties, which is a key part of understanding geometric shapes overall. Now, let's talk about rotational symmetry. Essentially, if you rotate an object and it looks exactly the same as it did before the rotation, we say that the object has rotational symmetry. The point around which this rotation happens is called the center of rotation. The angle through which we rotate the object is known as the angle of rotation. For example, a half turn, which is a 180-degree rotation, or a quarter turn, which is a 90-degree rotation. It's important to note that rotation can be done in either direction, clockwise or anti-clockwise, and the object will still be considered symmetric if it looks the same after the rotation. And when we complete a full 360-degree turn, the number of times the object appears exactly the same during that turn is called the order of rotational symmetry. This concept helps us understand how many positions an object can occupy and still look identical, which ties into the overall theme of symmetry and pattern recognition. Thank you.